A long coaxial cable carry a uniform volume charge density rho on the inner cylinder radius A and a uniform surface charge density on the outer cylindrical shell radius B. This surface charge is negative and is of just like magnitude that the cable as a whole is electrically neutral. Find the electrical field in each of the regions A, I. First, inside the inner cylinder, S greater than A, B, S more than A but greater than B, and C. Outside the cable, S more than B. Plot electric field as a wave function of X. First, for S greater than A, indicate the A equal to 2 pi SL and Qn cos equal to rho d tau and d tau equal to pi s square L. So electric field is rho s over 2 epsilon 0 with unit vector s. And for S more than A but greater than B, Q equal to rho d tau and rho d tau equal to rho pi a square L. So electric field equal to rho a square over 2 epsilon 0 s. And for the outside, from Gauss law and Q equal to 0, so electric field equal to 0. And if we plot the graph, we will have the graph here. From 0 to A is increased linearly. Okay.